All right, so chapter 4 review. Question number 1 says, a construction company is assembling a slide in a children's playground. The slide is 8.3 meters long. If the slide can have a maximum slope of 35 degrees, how high can the top of the slide be? So the slide itself is 8.3 meters long. So I don't know which way you want your slide to go, but let's say it goes down this way. So 8.3 is the length of the slide. The slide can have a maximum slope of 35 degrees. So 35 degrees looks like it would probably be there. What do you think? Do you think that's maximum from the ground up? Do you think that would be reasonable to put it there? Yeah, I don't think we'd want to put it here. You wouldn't want to put 35 degrees here because that's not a slope. That's from the vertical. No, we don't go out there. We go kind of from here. So that'll be a 90-degree angle, right? This is your slide, and there's your stairs that kids climb up. Did you guys like doing slides when you were young? Yeah. In the playground? Slides were awesome, right? Okay, so how high can the slide be? So I guess that is saying from the, wherever the top was here on my diagram there, top to the bottom. So it's this one. So the triangle has a 35 degrees here. The H is the opposite side, and this is the hypotenuse. So which trigonometry function or trigonometric function should we use that involves opposite and hypotenuse? Shout it out. Sine, right? Because it's so katoa, right? And that so is opposite divided by hypotenuse. So the one that involves opposite and hypotenuse, that's the one we're going to use. So please be careful. You go sine 35 degrees equals opposite is h. I don't know what h is. I'm going to put that over the hypotenuse, which is 8.3. And then to solve for h, I multiply both sides by 8.3. Those cancel out over there, and then h is just equal to this. Please make sure your calculator's in degrees, I guess, if you're talking about degrees. So mine, because I use this in other classes, sometimes I have it in a different mode. So there we go. It's in, oh, actually I switched it from degrees. So degrees, and then, so 8.3 times sine 35. 4.76. So what does that round to? Yeah. So did you guys get A? Anybody get A before I showed you that? Yes? All right, good job. Good job. Okay, let's keep moving on. Xavier is installing 2 sections of pipe. The first section is 5.5 meters long and makes an angle of 18 below the horizontal. So here's the horizontal. 18 degrees would be right here. 18 degrees below the horizontal. The second section of pipe is attached to the end of the first one with a bend. The second pipe is 4.4 meters long and makes an angle of 30 degrees below the horizontal. So it looks like it's going to go steeper down here like this, right? This is 30. That makes sense? There's a little bit of an angle there. These lines aren't very straight. Apologize. Okay, so 18 here and then 30 here. What is the total drop from the start of the first pipe to the end of the second pipe? The total drop from the start of the first, so from here, all the way down to this level. Okay? So what's this? That's what they're looking for. So because these sides, the pipes are at different angles, we have to kind of split it into 2 triangles, I guess. You see? So there'll be triangle number 1 up top, and then there'll be another triangle maybe here. Okay. Okay, so the distances on here are 5.5 and 4.4. Here, are you gonna try this one? Yeah, this one's not great for this. Okay. Okay, so we have, this question has got 2 parts to it, right? So how do I use this angle 18? Because that's actually outside of my triangle. Is there any way you can figure out how can I use that number and put an angle measure inside my triangle somewhere? Any ideas?
You can make it just a triangle that's
Oh, okay. So you could do this, you're saying.
Yes.
That's perfect. You could do that. That's one option. Now, if you're focused on this triangle, you can, another option would be that this 18 here and this angle has to add up to 90, right? Because the horizontal and then the straight down is 90 degrees. So 90 minus 18 is going to be what? 72. Very good. Yeah, very good. So that's another way. And the third way is that this is parallel to this right here, this imaginary line. And so this actually is 18 as well. Okay, so you have different options. I'm going to go with one of the options that's inside the triangle because I think maybe more people would choose that one. So I'm going to use one of these angles. And it really doesn't matter, I guess, which one you use, but I'm going to use the 18 over here, okay? Because this is the one I want. This is H1, or height 1. So that's like the opposite, and this is hypotenuse. So opposite and hypotenuse is sine. So sine of 18 degrees equals h over 5.5. And 5.5 over here. Thanks. And so we're going to get h1 there. 5.5 times sine of 18 is 1.7, looks like 1.6995. So 1.6995. You can probably round that to 1.7 would be okay too. Okay, and then we do the same thing for this one now, H2, height 2. Eden, you'll need this. Eden? So you guys go ahead and finish number 2, okay? Finish number 2 on your own. I'll give you a few minutes, and then I'll show you the answer there, okay? So, of course, when you get the second height there from that second little triangle, you add the two together. So how many of you got an answer there? Okay, so I'll unfreeze the screen. Did you get D? Okay, if you did, great. If you didn't get D, if you have any questions about why you got that incorrect, please let me know. Okay, to move on to the next one? Okay, let's do number 3. A cube has side lengths of 9 centimeters. So a cube is a 3-dimensional figure, right? Like it's like a cube of sugar. It's got square faces. So all the side lengths are the same. Kind of like that. So 9 centimeters, 9, 9, 9, right? If a hole is drilled from one corner straight through the center and out the other side. Oh, that's a tough one to draw, but let me try.
Does it look like it's going straight through the middle?
Yeah, it's going from one corner. I don't really have a cube on me. It's going from one corner. Here, I have something over here. I gotta be careful here. This is my tea from England. This came from Cambridge University. Okay, so let's say this is a cube, okay? So what we're doing is drilling from one corner, let's say this front corner, all the way through the middle, out this back corner here, you see, on an angle. So it's got to go right through the middle, from one corner to the other side. So if I were to draw that on here, okay, again, I think it's going to be kind of tough to draw, but let's say the hole starts here in this corner, it goes right through the middle and out the other corner. You know what I'm saying? So it's right there from the front corner to the back opposite corner, because that goes right through the middle. Okay, so we got to find that length. All right, that could be tricky. So I've got some triangles there. I've got let's see if we can make a triangle like this. Okay, so I've got 9 here. The bottom of this is going to be Here's the bottom corner. And then I have this. So right here, this yellow part is this part. All right. And then I have 9 in the vertical direction. That's right here, the 9 in the vertical direction. And then this length would be the whole. See? So I kind of have 2 triangles if I can lay it out like that. And then this is a 90 degree there. Whew, that's a lot of work to draw. But anyways, so let's see if we can give this a try. So this here is a 45 degree angle because this is going to be 9 as well, right? It's not drawn very well. It's on a bit of a slant there, but the bottom is 9, 9. So what is this length right here? Let's find that out. So option number 1 here, or step number 1, is finding out what this length is right here. So 9 squared plus 9 squared equals x squared.
162.
So that's 81, so it's 162 equals x squared. Square root of 162 is, did anybody get that?
12.7279.
12.72 or 73, let's go. Awesome. Okay, so that's what this one is, 12.73. Everybody see that, the first step? Second step then would be to find out what the length of the hole is now. I have another right triangle. So this is another right triangle, 9 on the side right here. And then this goes all the way over to the other corner. And this is the 12.73. And so I need to find y now. So the y is the goal there to find. Okay? So I can just use Pythagoras here, I guess, because they're right triangles, so I can use Pythagoras again. 12.73 squared plus 9 squared equals y squared. And if we do that on our calculator, we should get...
15.5.
Are you done already? Cool. Okay, I'll just double check here. Let everybody else have a chance. You're so quick over there. Plus 9 squared is 81. Oh, let's do that. So 243 and then square root that. Square root that answer is 15.59, 15.6. Okay, so now do you see a 15.59 centimeters on there? Look at that. I wouldn't expect you to draw this, but what you will have to know is how this kind of works, like what the sides are and what you're looking for. So this kind of question, tricky one as it is a two triangle question. Okay, so it's kind of like that. Okay, how's a big one? How's a tough one? Any questions though about that one? Okay, that was a hard one. All right, let's go to the next page. Now I can skip around a little bit if there's something you want to ask me about that you...
No, we definitely need 4.
Definitely need 4? Okay, let's talk about 4 then.
I forget how to do that.
Okay, which of the following cannot form a right angle triangle? Okay, so the one thing you want to remember with a right angle triangle, if it gives you side lengths, is you have to remember Pythagoras, which we just used, right? So that's important. And the C is always the largest one. Okay, this is the longest one. That's always the longest one. The C is always the longest side. So what you could do is kind of check to see if these numbers fit with this equation, I guess, eh? The other thing you might want to remember is there is a typical, like there's a right triangle, 3, 4, 5. That's a right triangle with side lengths 3, 4, and 5. That's an easy one to remember, 3, 4, 5. So if you have side lengths that are all multiples, the first one is multiple of 3, and then the same multiple of 4 and the same multiple of 5, if it fits within this pattern, then you know it's a right triangle. But probably the best is just to kind of quickly try the 2 small ones, square them and add them, and then see if it equals the square of the longest one. So the first one we'll try real quick. 16 squared plus 16 squared equals 34 squared. Let's just check to see if that works, because we might run into the right one before we get all through them. 16 squared, oops, plus 16 squared, 512. Now let's check 34 squared. Ah, not the same, right? That's not good. So it's not the first one, I guess. Okay, so just let's try some other ones. Remember, the longest one has to be C. 40, 42. Another thing you might notice, look at this one. So 40 and 42. Like 42 is barely longer than 40. You see that? So this, if this one is 40 and this one is 42, this side is going to be super small. It's not going to be super huge. Right? But now if it's, I guess if it's 40 and 42 like this, because that's the biggest one, I guess that could be. Right? Let's try it out. Let's try it out. 58 squared. Where am I? 58 squared. No, my bad. 42 squared plus 40 squared is 3364. Is that 58 squared? Ah, it is. Which of the following cannot form a right triangle? Oh, it asked for which one can't be a right triangle. So did we hit it already with the A?
Yes, but D can't.
D can't either?
Yeah.
Which of the following cannot form a right triangle? Okay, okay. And you're sure about this one? 17 square? Okay, let's try it.
It's like almost double the amount.
Is that right? Okay, all right. So we might have to think a little more deeply about this. Plus 5 squared equals 314. Oh yeah, that's gonna be no good either. Okay, so A doesn't, as far as our calculations, and D doesn't seem to, as far as our calculations go. So which of the following cannot form a right angled triangle? So what do you think we should? What do you think we should do now?
Why can't we just put A and B?
What's that, sorry?
We can't do A and B?
Nope. Okay, so right now the way it stands is that both A and D are correct answers. I think there's a typo in A because it's supposed to be just D. So A or D. Yeah, if that happens on an assignment, you can just put A or D, and I'll check to see if there's an error. If you're sure that one of them is, or if they're sure that there's more than one answer, yeah. That one, I'll have to check that one again. Okay, let's keep going. Short answer number 1. The sun is shining at an angle of elevation. So remember, elevation is always from the horizontal or the flat up. Okay, elevation is elevate, up. So angle of elevation, and a lot of students get this wrong because they go from the sun and like down, but no, it's an elevation from the ground. So here is the sun. Okay, awesome. Okay. If the building casts a 60-meter long shadow, how tall is the building? So here's the building that's casting a shadow, you see? So there's the building, and the shadow is 60. So here to here is 60. Cool. How tall? So we're looking for the height here. So what trig function do you think we should use? Because it's a right angle triangle, because buildings are built straight up and down. So you can always assume that a flagpole or a building always makes a 90. So ka toa, which one? Okay, this is opposite and this is adjacent. I heard toa. That's perfect. Yes. So tan, and remember it's always tan of the angle, so tan of 31 degrees equals opposite divided by adjacent. So opposite is h, adjacent is 60. Multiply both sides by 60, and I get h should equal just this value right there. So we'll do that. 60 times tangent of 31. 36.05. It doesn't say I have to round it to a certain number of decimal places, so 36.05 is fine. 2 decimal places is usually good. And should I just leave it like that, or should I add something else to it? Thank you. Please make sure you have your units on there, okay? So you got to look back to the question and see, oh, what units are involved here with the length. So I need to put a meter there, okay? I don't require a word sentence, but I do ask you to use your units, okay? Cool. All right. Calculate, oh, this is a good question. Calculate the area of this triangle. Recall, and I even give you the area formula here in this assignment, 0.5 or 1/2 times the base times the height. So I don't have the height or the base, so guess what? We have to find those. Now, can we find them given the information that we have? I sure can. If I want to find this one, according to 25, this side is the opposite side, so that's going to be my height. And this side is the hypotenuse because it's opposite the 90. So let's first of all find the height. So O and H, which trig function is that? Very good. Sine of 25 degrees equals O, which is the unknown H value, divided by 21.6, times both sides by 21.6. And my H is going to be 1.6 times sine 25. 9.13, we'll say. H. Everybody get that? Okay, now that's going to be centimeters, so just as long as I don't forget. So that's not my answer, so I'm not going to circle that yet, because that's just part of the puzzle, right? So now I need to find this B here. This is the base, which is the adjacent side. So I can use this number again. Which one has A and H? Which trig function is that? Very good. Cosine now of 25 involves the adjacent side, which is the unknown B, divided by hypotenuse, because it's so ka toa. So 21.6. Again, multiply both sides by 21.6. And I'm left with B is, you got 19 point something? Yeah, okay, that sounds about right. Cos 25. 19.58, beautiful. 19.58 centimeters. Now, I'm not going to circle that one either, because I'm not quite done yet, right? So always, when you think you're done a question, always go back and just read the question real quick and say, am I providing the answer to the question? It's very, very important, because sometimes we lose track of what we're actually trying to find. So we go back and we just double check, and I'm like, oh, I don't need these values. That's not that right. These are not the answers to the question, but I do need them to find the answer. So now I'm going to do area equals 1/2 or 0.5, the base, which is this number, times the height, which is this number. Which should be about 89.37. I use the full decimal for the 19 one, so mine might be a little different than yours, but 89.37. What do you guys get?
I took a 3 or
89.38 you get?
Yeah.
Okay, so yeah, you guys use the rounded up variable, so let's use yours. So 89 point, you said 38. Cool. And that's what you get if you use just this decimal. You see, on my calculator, I use the full decimal, which you wouldn't have to do. If you did do that, though, use the full decimals, you would still get the answer correct, okay? All right, now am I done? Do I need to add anything else? Ah, units, thank you. Now be careful with the units. When we're talking about area, they are length units, but What else do we have to do to make this unit correct for area? Very good. Squared, yes. Awesome. And then I circle my one answer that I'm looking for. That's perfect. Okay. Now I know this is kind of all over the place, and I will be able to follow your work if it's like this. Okay. If you do some of your steps over here and then jump over here and then do another one over here on the side and then and big arrow going over here and you do more work over here and then a stick arrow down here and you know that's pretty tough. Or if you make a mistake and you scratch out half of your work like that, like this right there is a mess. But I can follow your work pretty well if you have it at least kind of clearly laid out.
Can I wash my face since
Yes, please go. All right. Okay, you guys are doing great. Let's see what else we got going here.
Who's the last question?
3, 4. Sorry, what?
Yeah, that one, please.
Okay, we'll get to it. We'll get to it. All right. Let's take a look at let's take a look at 3 because there's no diagram for 3. Sometimes the questions with no diagrams can be a bit tough. Okay, we'll get to that last question. Yeah, I'm keeping an eye on the time. We'll make sure we get to the last one. Okay, so a right-angled triangle has a base of 11.7. So I'm just going to randomly draw a right-angled triangle and make 11.7 here. And a hypotenuse of 16.1. 16.1 there. What's the measure of the angle between these two sides? So when it says the angle between these two sides, that's this side and this side, so it's this angle right here. Okay. This is a right triangle because it says it's right angle triangle. So you have some options here. The best option would be just to use your trig function again. This is adjacent side to the angle, right? And this is the hypotenuse. So which trig function should we use there?
Cosine.
A and H, very good, cosine. So cosine of unknown theta has a ratio of adjacent side divided by hypotenuse side. Who remembers how I solved for this angle theta now? Who remembers what inverse trig, very good, yes. So this is cos to the -1 of this ratio over here. All right. So second function cos 11.7 divided by 16.1. And that gets me an angle of 43.39 or 43.4. Does it say which I should? Doesn't say. So again, 2 decimal places is always awesome. 2 decimal places is always great. 43.39. 43.39. Lots of times we just do 1 decimal place for angled degrees, but I'll accept that too. But 2 decimal places is always a good idea. Okay, so that's what I got. Did you guys get that too? I should have checked. You guys else got, yeah? Okay. Okay. So I'm going to leave some of these for you guys to do. So number 4, what do we have left here? Number 4, and then the problem? Okay. Okay, so number 4, I'm going to get you started on both of these ones. I'm not going to do the whole thing for you, but I'll try and see if I can figure out where you kind of are stuck, okay? So for number 4, the area of triangle ABD. So that is the big triangle, okay? So area of triangle, right away I think of the formula, which is 1/2 base times height, right? So guess what? This is the base. I need to find what this height is. So that's going to come from finding this side right here and finding probably, I guess, this side right here. Well, that's, yeah, not probably, but that's where it's going to come from. Is there any way that I don't have to separate this into 2?
Yeah. You don't have to. The other square is like on this.
Okay, is this 8.3 the whole side length here?
Yeah.
That's what it looks like, doesn't it? Is it?
So, yeah.
Because it's kind of in the middle, right? So it'd be in the middle of this long side. Okay. So do I even need to worry about this little line here?
No.
I have 46 degrees. I have the base.
Wait for the base.
The base is the whole side, right? The area of triangle ABD. ABD. 1/2 base times height. Yeah, all I need to find is the h here. I don't think I even need this. I don't even need this. Like I don't need either, both of these. I just need one of them, I think. I'm doing this for the first time too, so. So let's see if we can find h here. So let's just say we have this one triangle that looks like this, right? Here's the 46. Here's the 8.9 and the h. I'm going to do opposite over adjacent. So that's going to be TOA. Okay, opposite side, adjacent side. So yeah, I don't think I even need to worry about this little line in the middle of the triangle. So tangent of 46 equals 8.9, that's opposite side divided by h. Okay, so I'm going to let you guys do the rest of this. You're going to want to solve for h, okay? And then you're going to use your triangle area formula. 1/2 8.9, 1/2 the base times this height. So there's just two small steps that I'm going to let you guys do on your own there. Take a moment to look at that. So just to give you a start on number 1, you want to find the area of this figure. Okay, a landscape designer is designing tile for an outdoor patio. How many square meters of tile will she need? So here's the patio. So we want to find the area, right? What's the area of this? So it's a bit tricky because that's a strange shape, but you could pretty easily turn this into two different triangles, right? So you could go from this corner to this corner. Now that's kind of cutting this 65 up a bit, and you don't know exactly if it's half of 65 each side. You don't really know. But what you do know is you have this length, you have this length, you have this angle. So you could find out, could you find out what this side length is right here? Do you guys know? Oh. Do you guys know the cosine law? No, you guys don't know the cosine law.
Yeah.
I don't think you need to use the cosine law for this one. Okay.
Well, I split it into two triangles and a rectangle.
All right. Is there any way? Is there any way? Okay, so that one would require some formulas that we don't know yet. So, what else can we determine here from, like, for example, I'm missing this angle. Can I find this angle given the information?
360 minus all the other angles.
Okay, so what you might remember is that all the angles of a quadrilateral have to add up to 360. So 360 is the total. If I subtract what I'm given, 72 minus 65 minus 90, right? Then I could find out what this angle is. Okay? So that's this angle. All right, well, did anyone calculate that here yet?
It's 133.
133, okay. That's right, 133 there. Okay. Okay, this is a 90-degree angle, so that's kind of nice. I might have a right triangle if I drew this line again, but then I don't really know any other sides or angles. So,
You can draw a
What do you think?
straight line from the angle 72 to the right side. Not like the middle of it.
like here?
Yeah, so you have two triangles if you go down from 130.
Okay, so you want to split it here, like that?
Yeah, and then you have another triangle if you.
And then you have another triangle here, like that?
Yeah.
Okay. So let's see, what does that do for us? That gives us a right triangle down here where I have an angle and a side. So I could find either this side or I could find this side. Okay, that might help. If I draw a line through these other angles though, I kind of lose those angles a bit. Is there, that might be a little tricky. Well, I guess you would have
Yeah, you're given, if you could subtract 33 with 90, then you have.
Oh, I see. Okay. All right. I'm going to stop writing here, but I'm going to keep going with what you're talking because I want you guys to finish this. So right here, that's very good. Right here, if you drop this line straight down to make a 90 here, then this has to be like a rectangle, right? So that means that this whole angle of 133 is actually 90 plus something else, or 90 plus 43. So in this triangle right here, this angle you can find out, this is 43. Okay, so now I have this angle given, 43, and then I can use this side and I can find maybe, what, this side? How does this help me? I guess I could find this side, right? Then I could use 1/2 base times height. Yeah, I'm gonna need to find several pieces of this. So I've got X, Y, this one Z here, I can find this one. I gotta find this one too, H, this height. Yeah, okay, so there's multiple pieces for this one. So I'm gonna let you guys work on this. What I will do though is at the end when you've had a chance to work on it, I'll put the answers on this page on the video and you can watch the video later to see if you, when you're done, see if you got your answer correct. Okay? All right, so you have the rest of the class, which is about 10 more minutes to finish this up.